Hello, future engineers, subscribers, viewers, and students. Here is another video in Engineers in Progress, particularly on composite functions in algebra in preparation to sketching graphs of functions. But before that, sketching curves defined by equations. Although for those curves, some are not uh, functions, but it's a good start for you to be familiar with the different curves. So we have exercises here, 14 sets of exercises. If f of x is x minus 5 and g of x, x squared minus 1, find f plus g. Just read that as we solve the first part. We are also required to determine the domain of the function in all problems. So 14a, f of x is x minus 5, g of x, x squared minus 1. Therefore, f plus g is x minus 5 plus x squared minus 1. Simplifying, that's x squared plus x minus 6. And since we can substitute any value of x without a problem, the domain is the set of real numbers, negative infinity to positive infinity. 14ab, f minus g, so that's x minus 5 minus quantity x squared minus 1. Simplifying, that's negative x squared plus x minus 4. So that's the resulting function, and the domain is the set of real numbers. There's no denominator, and there's no radical also. 14c, ac, we have f times g. So that's quantity x minus 5 times quantity x squared minus 1. Distribute and simplify, we have x cubed minus x minus 5x squared plus 5. Simplifying, the f times g is x cubed minus 5x squared minus x plus 5. With the domain, no worries, so negative infinity to positive infinity, or the set of real numbers. 14ad, f divided by g, so that's quantity x minus 5 divided by x squared minus 1. So there is denominator this time. The denominator is 0 when x is plus minus 1. Therefore, the domain is the set of real numbers except where the denominator is 0 or except x is plus minus 1. 14ae, g divided by f, so that's x squared minus 1 over x minus 5. And this time, the denominator is x minus 5, which is not defined when x is exactly 5. Therefore, the domain is a set of real numbers except x is 5. 14ba, f of x, x plus 1 over x minus 1, g of x 1 over x. Therefore, f plus g is x plus 1 over x minus 1 plus 1 over x. LCD is x times x minus 1, and when we simplify, we have x squared plus x minus 1 all over x times x minus 1. Simplifying the numerator, we have resulting function x squared minus 1 over x squared minus x. And the domain is the set of admissible values of x. These functions are undefined when x is 0 and when x is 1. Therefore, the set of real numbers, the domain is the set of real numbers except 0 and positive 1. 14b, we have f minus g, so x plus 1 over x minus 1 minus 1 over x. LCD again is same as that, x times x minus 1. Simplifying, we have x squared plus x minus quantity x minus 1, so x squared plus x minus x plus 1 all over x times x minus 1. So simplifying, we have f minus g is x squared plus 1 over x squared minus x. So the domain is set of real numbers except where x is 0 and when x is 1. 14bc, we have f times g, so that's quantity x plus 1 over x minus 1 times 1 over x. Simplifying, we have f times g is x plus 1 over x squared minus x. So the domain is the same as 14b, b, and 14 bc. 14 bd, we have f divided by g. So that's x plus 1 over x minus 1 divided by 1 over x. Simplifying, this becomes numerator, so x squared plus x, numerator, all over x minus 1. So the domain this time is the set of real numbers except x is 0 and x is positive 1. Because when x is 0, this becomes undefined. F of x will be undefined when x is 1. 14 BC, g divided by f, g divided by f, 14 e, 14 e rather. So we have 1 over x divided by f, x plus 1 over x minus 1. If you simplify this, that's x minus 1 all over x times x plus 1, or x minus 1 all over x squared plus x. So the domain is where the denominator is not 0, so set r except for this result we have x is 0, x is not 0, and x is not equal to negative 1. And for the original function f of x, it becomes undefined when x is exactly 1. So the domain this time is set r except 0 and x is plus minus 1. So that's it for the domain of this function. So for 14c, let us continue. The requirement is still the same. You have to evaluate the resulting function, then restate the domain of the resulting function, or the domain of the function. So 14c, if f of x is square root of x and g of x, x squared minus 1, find f plus g, b, f minus d, c, f times g, d, f divided by g, and e, g of f, and find the domain in 14c. So we have f of x, f plus g is square root of x plus x squared minus 1. That's already the answer. And since there's no problem with x squared minus 1, the domain is a set of real numbers except for f of x, which is square root of x. The domain for this case is open quantity including 0 to positive infinity. Therefore, the domain of the resulting function is open bracket 0 to positive infinity. Negative is not included because we have square root of negative undefined. 14cb, f plus g, f minus g. So that will be square root of x minus quantity x squared minus 1, and that's equal to square root of x minus x squared plus 1. And again, the domain is based on the domain of square root of x. So it's the same, open bracket 0 to positive infinity for the resulting domain. 14c, f times g, that's square root of x times quantity x squared minus 1. And we leave the answer that way. And since the other function has no restriction for its domain except for the first, so the domain is open quantity, open bracket 0 to positive infinity. It's the same. Then 14cd, we have f divided by g, so that's square root of x divided by quantity x squared minus 1. For the denominator, x should not be equal to plus minus 1. And since here the numerator, the domain is open bracket 0 to positive infinity, we note that 1 is also a restriction in the both in the numerator and the denominator. So therefore, negative 1 is also not allowed, but negative 1 is outside open bracket 0 to positive infinity. So therefore, the domain is open bracket 0 to 1, because 1 is not included, close parenthesis, union with open parenthesis 1 to positive infinity. So open bracket 0 to 1, union with open parenthesis 1 to positive infinity. And lastly, 14 C E G divided by F. So that's x, quantity x squared minus 1 over square root of x. Then the domain is 0 is not included this time because square root of 0 is 0. So this becomes undefined. So the domain is just like this, but 0 is no longer included. So 0 to positive infinity. That's the domain, 0 to positive infinity. So that's it for this video. I hope that you learned something which is important for your engineering life.